Question 1. Through careful analysis of a recovery operation during a commercial rooftop unit service, technician Israel encounters a mixed refrigerant situation. The unit was labeled for R400 TINA, but pressures and operating conditions suggest contamination with R22. Israel must decide the proper course of action to safely handle and recover the refrigerant. What is the most appropriate action for Israel to take in this situation? A. Recover the refrigerant into a standard R400 TINA recovery cylinder and label it accordingly. B. Vent the system slowly outdoors while monitoring for safety hazards. C. Use a recovery cylinder designated for mixed refrigerants and label it clearly. D. Attempt to separate the refrigerants using on-site equipment. Answer. Correct answer. C. Explanation. According to EPA Section 608 and RA Guideline Q, when a technician encounters mixed or contaminated refrigerants, they must not recover into standard cylinders used for pure refrigerants. Instead, they must use recovery cylinders clearly marked for mixed refrigerants and handle them as non-recyclable waste, sending them to certified reclamation facilities. Option C adheres to these rules. Option A violates EPA standards. Option B is a violation of the Clean Air Act. Option D is not permitted unless using certified equipment in a reclamation facility. Question 2. When evaluating the merits of coordinating an emergency HVACR spill response, a facility response leader must assign personnel according to EIC's principles. Mr. Daniels, a senior HVACR tech, is asked to assume a leadership role but lacks EIC's training. What is the best decision the incident commander can make under these circumstances? A. Allow Mr. Daniels to lead since he knows the system best. B. Assign Mr. Daniels as a technical advisor under a trained EICS officer. C. Postpone the response until Mr. Daniels completes EICS training. D. Let Mr. Daniels act as both commander and technician to save time. Answer. Correct answer. B. Explanation. Under the National Incident Management System (NIMS) and EICS protocols, technical expertise is valuable but must be integrated within trained EICS roles. The correct approach is to assign untrained individuals to advisory or support positions under formally trained EICS leadership. Option B ensures compliance and utilizes Daniels' expertise safely. Options A and D break EICS structure. Option C delays the response unnecessarily and violates emergency response time expectations. Question 3. Throughout the course of a high-pressure refrigerant leak response in a mechanical room, technician must select appropriate PPE. The environment has poor ventilation, high concentrations of refrigerant vapor, and potential for oxygen displacement. Which PPE combination is most appropriate for this situation? A. Safety goggles, nitrile gloves, and steel-toe boots. B. Full-face respirator, chemical-resistant gloves, and flame-resistant coveralls. C. Surgical mask, latex gloves, and standard workwear. D. Hard hat, face shield, and earplugs. Answer. Correct answer. B. Explanation. Refrigerants like R400 TINA can displace oxygen and pose asphyxiation risks in confined or poorly ventilated spaces. OSHA 1910 subpart I requires respiratory protection, full-face respirator with proper cartridges, chemical-resistant gloves, and clothing appropriate for potential exposure. Option B is comprehensive. Option A lacks respiratory protection. Option C is insufficient for chemical or respiratory hazard. Option D addresses unrelated hazards. Question 4. In a modern context of refrigerant management and environmental responsibility, leak detection has shifted from reactive to proactive. Which of the following best represents an advanced, compliant approach to refrigerant leak detection in large commercial systems? A. Wait for pressure drop, then visually inspect for oil traces. B. Install continuous electronic leak monitoring systems. C. Use soap bubbles during every scheduled maintenance. D. Perform leak checks only when customers report issues. Answer. Correct answer. B. Explanation. EPA Regulations 40 CFR Part 82.157 now require continuous monitoring or regular inspections for systems above 50 pounds refrigerant. Electronic leak detection is considered best practice for early identification, environmental protection, and regulatory compliance. Option B reflects this. Option A and C are reactive and labor-intensive. Option D. Violates the EPA's required leak inspection frequency. Question 5. In what ways can understanding subcooling and superheat help technicians like Islang during HVACR emergency diagnostics? A. They help identify wiring faults in control panels. B. They provide insight into compressor lifespan. C. They reveal airflow patterns inside ducts. D. They indicate refrigerant charge and heat transfer performance. Answer. Correct answer. D. Explanation. Superheat at the evaporator outlet and subcooling at the condenser outlet are essential diagnostics for assessing proper refrigerant charge and system efficiency. Incorrect values indicate undercharge, overcharge, or metering device malfunction. Option D is accurate. Wiring issues A. Compressor longevity B. And duct airflow C require separate diagnostics. Question 6. Examining the consequences of improper refrigerant venting during a system decommissioning, Mr. Lopez intentionally releases refrigerant outdoors to expedite the process. Which legal and environmental implications will he most likely face? A. He may be fined under OSHA guidelines. B. He risks damaging the equipment warranty. C. He could face EPA penalties and certification suspension. D. He will be warned but not punished if no harm occurred. Answer. Correct answer. C. Explanation. Venting refrigerants is a direct violation of the Clean Air Act, Section 608. Technicians may face fines exceeding $44,000 per violation, loss of certification, and potential criminal prosecution. OSHA governs workplace safety but not refrigerant venting. Equipment warranties B. are irrelevant to legal consequences. EPA enforcement does not require observable harm. D. Question 7. From multiple perspectives, refrigerant-related fire hazards must be assessed not just by ignition potential but also toxic byproducts. In a recent warehouse leak, an R1234F release was followed by a fire. Why is this incident particularly dangerous? R1234F is highly flammable and forms phosgene gas when burned. B. The refrigerant decomposes into harmless carbon dioxide. C. The fire was unrelated. The refrigerants are non-combustible. D. The leak caused high noise levels which confused workers. Answer. Correct answer. Explanation. R1234F is classified as mildly flammable. When it combusts, it can form toxic gases, including hydrogen fluoride and carbonyl fluoride, not phosgene directly, but similarly dangerous. This presents serious health hazards. Option A highlights flammability and decomposition risks. Option B is false. C ignores flammability ratings. D is irrelevant. Question 8. Based on the information gathered from a tripped breaker and signs of overheating in an air handler control cabinet, technician O'Donnell finds that the stuck capacitor has failed. What likely caused the failure? A. Improper thermostat calibration. B. Excess refrigerant charge. C. Voltage surge or poor power factor. D. Dirty air filters. Answer. Correct answer. C. Explanation. Capacitor failure often results from electrical anomalies like voltage spikes, aging dielectric material, or harmonic distortion in power supply. Power factor issues increase capacitor load. Option C matches this concept. Thermostats A. Refrigerant charge. B. Or filters. D. Do not directly affect capacitors. Question 9. In light of recent developments, the handling of mildly flammable refrigerants requires updated technician training. Mr. Gregory stores multiple R cylinders in a mechanical room without ventilation. Which hazard is most concerning in this scenario? A. Asphyxiation from co-buildup. B. Sudden equipment overpressurization. C. Accumulation of flammable gas leading to ignition. D. UV radiation from cylinders. Answer. Correct answer. C. Explanation. Our refrigerants require specific storage conditions. Accumulated vapors in enclosed spaces create fire explosion risks. Mechanical rooms must have adequate ventilation and leak detection per Bill 60335-240 and ASHRAE 15. Option C addresses this. A. Misidentifies the gas. B. Relates to system faults, not storage. D. Is baseless. Question 10. While examining an ammonia leak in a refrigerated warehouse, Bautista must decide whether to ventilate the space or activate the suppression system first. He notices workers are still inside. What should he do immediately? A. Ventilate the room to clear the air. B. Activate suppression and evacuate personnel. C. Trigger alarms and initiate immediate evacuation. D. Enter with SCBA to retrieve employees. Answer. Correct answer. See explanation. According to OSHA 1910.119 and ER standards for ammonia refrigeration, the first priority is life safety. Evacuating occupants and alerting emergency responders takes precedence over controlling the leak. Option C follows emergency response hierarchy. Suppression B is secondary. Ventilation A may worsen dispersion. Self-entry D is extremely dangerous without backup. Question 11. In the absence of a functioning compressor in a walk-in freezer, technician Coleman notes a sharp drop in suction pressure while the discharge line remains warm. The motor is running, yet no cooling occurs. What is the most likely mechanical issue? A. The expansion valve is overfeeding the evaporator. B. The compressor valves are damaged or leaking. C. The condenser fan motor is stuck in the off position. D. The system is in defrost mode. Answer. Correct answer. B. Explanation. A running compressor with low suction and warm discharge but no cooling typically indicates internal valve damage. Suction gas is not being compressed effectively, leading to poor heat transfer. Compressor valve failure leads to inadequate pressure differential and refrigeration cycle disruption. Option B fits this scenario. A would result in flooding and high suction pressure. C would cause high discharge pressure, not low suction. D would shut down the compressor. Question 12. Under the assumption that a confined mechanical room requires refrigerant leak response, Mr. Alvarez must assess entry safety. There is no forced ventilation and refrigerant levels may be hazardous. What is the first step before entering? A. Put on gloves and goggles. B. Enter quickly to check conditions. C. Test atmospheric conditions with a gas monitor. D. Notify building maintenance for entry permission. Answer. Correct answer. C. Explanation. Confined space entry requires atmospheric testing before entry per OSHA 29 CFR 1910.146. Testing ensures sufficient oxygen and absence of toxic or flammable gases. Refrigerants can displace oxygen or present toxicity risk. E.g. R123. Option C meets safety protocols. PPEA is important but not first. B risks exposure. D is procedural but doesn't ensure safety. Question 13. The foundation of HVACR emergency response includes proper containment procedures. Mr. Howard arrives at a commercial site with a ruptured R134 cylinder actively leaking in a storage area. What should he do first? A. Ventilate the area and activate fans. B. Evacuate personnel and cordon off the leak area. C. Call the refrigerant supplier for instructions. D. Begin refrigerant recovery immediately. Answer. Correct answer. B. Explanation. Emergency protocols under EPA and OSHA require immediate protection of life and containment. Evacuation and isolation come before recovery or ventilation. R134 can displace oxygen and cause asphyxiation. Option B follows in EPA 704 and EPA Emergency Response Guidebook protocols. A can spread vapors. C is secondary. D is unsafe until the area is secured. Question 14. By comparing pressure loss in piping systems, Mr. Braun identifies unusually high static pressure readings in a chilled water return line. The system flow rate is normal. What is the most likely explanation? A. The evaporator coil is undersized. B. The return piping has become partially blocked. C. The compressor speed is too low. D. The expansion valve is overfeeding refrigerant. Answer. Correct answer. B. Explanation. A partial blockage increases resistance to fluid flow, causing elevated static pressure. Bernoulli's principle and Darcy-Weisbach equation confirm this correlation. Option B is correct. Undersized coils A affect heat transfer, not pressure. C affects refrigerant, not water loop. D is unrelated to water pipe. Question 15. With respect to interagency coordination, Mr. Stevens is handling A fire-related refrigerant emergency with local responders. Which communication protocol ensures compliance and efficiency? A. Use HVACR-specific technical codes in all messages. B. Defer all communication to building security staff. C. Follow standardized NIMS communication protocols. D. UCB radios and personal phones to communicate. Answer. Correct answer. C. Explanation. NIMS National Incident Management System mandates structured communication in emergencies. Common terminology, clear chain of command, and compatibility across systems ensure efficient operations. Option C. Follow DHS and FEMA best practices. HVACR codes may confuse responders. B is a breakdown in command. D may violate FEC and safety regulations. Question 16. Taking into account system balance and efficiency, why is the proper sizing of metering devices such as ESVS critical in an emergency HVACR application? A. They control motor speed in compressor units. B. They regulate condenser fan operation. C. They manage refrigerant flow to match evaporator load. D. They shut down the system when leaks occur. Answer. Correct answer. C. Explanation. A thermostatic expansion valve (TSV) modulates refrigerant flow to match evaporator demand. Maintaining correct superheat. Improper sizing can cause flooding, starvation, or system damage, especially critical during recovery or emergency operation. Options A, B, and D confuse the role of the TSE. Question 17. From a practical standpoint, Mr. Naylor finds an unconscious coworker near a leaking refrigeration line. The worker is unresponsive and not breathing. What is Mr. Naylor's first action? A. Start chest compressions immediately. B. Remove the victim from the contaminated area. C. Call 911 and wait for medical assistance. D. Attempt to seal the leak before attending to the victim. Answer. Correct answer. B. Explanation. Before CPR, the victim must be moved to a safe location. Performing CPR in a contaminated area endangers both parties. Once in fresh air, Mr. Naylor should call emergency services and begin CPR if trained. Option B is correct. A is dangerous if the environment is toxic. C is necessary but not first. D delays critical life-saving action. Question 18. To illustrate this point, Mr. Ortiz uses a digital micron gauge during refrigerant evacuation but receives inconsistent readings. What could cause these inconsistencies? A. The gauge is too far from the vacuum pump. B. The refrigerant charge is too high. C. The TSB is stuck open. D. The system is over-insulated. Answer. Correct answer. Explanation. Micron gauge placement is critical. It should be installed far from the pump, ideally at the system's farthest point. Placing it too close gives false low readings due to pressure gradient. Option A explains this. B refers to charging, not evacuation. C doesn't impact vacuum readings. D is unrelated. Question 19. The prevailing attitude toward rooftop unit servicing requires fall protection. Mr. Chen is servicing a rooftop chiller during a refrigerant alarm. Which fall protection measure must he implement? A. Tie a rope around the waist secured to the unit. B. Work only near the edge to avoid slipping. C. Use a full body harness with a secured anchor point. D. Call for a lift to bring the unit to ground level. Answer. Correct answer. C. Explanation. OSHA 1926 Subpart M mandates fall protection. G. Full body harness, lanyard, secure anchor for work above 6 feet with edge exposure. Option C complies. Rope stay illegal. B is unsafe behavior. D is impractical and avoids the protection responsibility. Question 20. One might argue that after multiple leak incidents in a cold storage facility, simply repairing the leaks is insufficient. What is the best approach to long-term mitigation? A. Replace all refrigerant lines regardless of condition. B. Install larger compressors to increase flow. C. Conduct a root cause analysis of system design and maintenance. D. Perform weekly leak checks only. Answer. Correct answer. C. Explanation. Root cause analysis. A CA is essential for systemic issues. It identifies design flaws, vibration, poor installation, or maintenance gaps contributing to leaks. Option C enables long-term resolution. A is wasteful and reactive. B may exacerbate leaks. D is helpful but insufficient without identifying root causes. Question 21. Given the circumstances, technician Mr. Patel arrives at a site where an unknown refrigerant leak is causing an odor and dizziness among workers. The refrigerant cylinder label is missing, and the system uses multiple refrigerants over time. What is the safest initial approach for Mr. Patel to assess the hazard? A. Immediately enter the area with only gloves and goggles. B. Use a multi-gas detector calibrated for common refrigerants before entry. C. Request building evacuation and leave the area without further assessment. D. Attempt to locate the leak by listening for hissing sounds near equipment. Answer. Correct answer. B. Explanation. A thorough hazard assessment starts with non-intrusive monitoring. Using a multi-gas detector designed for refrigerants ensures the technician identifies oxygen levels, flammability, and toxicity before entry, complying with OSHA 1910.146 confined space standards and EPA safety recommendations. Immediate entry without testing. A. Risks exposure. Complete evacuation. C. With assessment might delay response. Listening for leaks. D. Is ineffective without detection equipment. Question 22. During the process of refrigerant recovery in an emergency, is TRAN uses a recovery machine designed only for CFCS. The system contains HFC refrigerants. What risk does this pose? A. No risk. All recovery machines are universal. B. The machine may malfunction or fail to recover refrigerant efficiently. C. It will cause the refrigerant to change chemical composition. D. It would improve the recovery speed due to compatibility. Answer. Correct answer. B. Explanation. Recovery machines are specifically designed and certified for certain refrigerants based on pressure, temperature, and chemical properties. Using a new recovery machine and HFC refrigerants risks equipment damage, incomplete recovery, or safety hazards due to incompatible pressure settings. Option B reflects this. Refrigerant chemical composition cannot be changed by the machine. C. Options A and D are false. Question 23. To what degree does the presence of flammable refrigerants, our classification, change fire safety protocols during emergency HVACR operations? A. No changes if fire safety protocols remain the same. B. They require stricter ignition source control and enhanced ventilation. C. They eliminate the need for fire suppression systems. D. They allow use of electrical tools without explosion-proof rating. Answer. Correct answer. B. Explanation. Our refrigerants are mildly flammable and require additional fire safety measures, including controlling ignition sources, ensuring mechanical ventilation to prevent accumulation of flammable vapors, and compliance with NFPA 90 and ASHRAE Standard 15. Options A, C, and D disregard increased hazards and regulatory requirements. Question 24. From a historical standpoint, brazing refrigerant lines without proper purge gas is common but problematic. Mr. Lopez attempts a quick repair on an R400 Tina system but fails to use nitrogen purge. What is the likely consequence? A. No effect. The nitrogen purging is optional. Oxidation inside the pipe causing contamination and future leaks. C. Improved seal strength due to nitrogen presence. D. Reduction of refrigerant charge needed. Answer. Correct answer. B. Explanation. Oxygen and moisture react at brazing temperatures, forming oxides and scale that contaminate the system, clog metering devices, and cause leaks. Purging with nitrogen prevents oxidation by displacing air. Option B correctly identifies the consequence. They C and D are incorrect or misleading. Question 25. In response to a refrigerant spill incident, technician Kim completes on-site mitigation and system recovery. What is the next critical step according to EPA regulations? A. Resume normal operations immediately. B. Document the incident details and report to the EPA if thresholds are exceeded. C. Dispose of all recovery equipment. D. Notify the equipment manufacturer only. Answer. Correct answer. B. Explanation. EPA Section 608 requires documentation of refrigerant releases and reporting spills exceeding certain quantities, e.g. 10 pounds, to authorities. Proper reporting aids regulatory compliance and environmental protection. Resuming operations without reporting violates the law. Disposing equipment, C, or notifying only manufacturers, D, are inadequate responses. Question 26. When considering the effect of ambient temperature on refrigeration cycle efficiency during an emergency, Mr. Ahmed notes a significant rise in condenser pressure. What thermodynamic principle explains this? A. Increased ambient temperature reduces heat rejection, causing pressure rise. B. Lower ambient temperature increases compressor workload. C. Ambient temperature does not affect condenser pressure. D. High condenser pressure is due to expansion valve failure only. Answer. Correct answer. Explanation. According to thermodynamics, the condenser rejects heat to ambient air. Higher ambient temperature reduces the temperature difference, lowering heat rejection efficiency and increasing condenser pressure. This increases compressor work and risk of system shutdown. Option A is correct. Options B, C, and D misunderstand or oversimplify the phenomenon. Question 27. From the perspective of electrical safety, Mr. Dawson discovers an improperly grounded HVACR unit during an emergency shutdown. What hazard does this pose? A. No hazard as grounding is optional. B. Potential for electrical shock and equipment damage. C. Improved system performance. D. Increased refrigerant leak risk. Answer. Correct answer. B. Explanation. Proper grounding prevents stray voltage, electrical shock hazards, and reduces equipment damage risk from faults. OSHA 29 CFR 1910 subpart S mandates grounding. Option B reflects these hazards. Options A, C, and D are incorrect or irrelevant. Question 20. Several experts suggest that efficient resource management during an HVACR emergency includes prioritizing tasks. Is real right, sir? A large ammonia leak with limited personnel. Which task should be prioritized? A. Documenting the leak for future reference. B. Recovering refrigerant before securing the area. C. Evacuating personnel and securing the perimeter. D. Starting system repair immediately. Answer. Correct answer. C. Explanation. Life safety is paramount. Securing the area and evacuating people minimize casualties. Only after this can recovery and repairs proceed safely. Prioritizing documentation A, or recovery B, without evacuation risks lives. Repairs D require a safe environment first. Question 29. Among the various factors affecting refrigeration efficiency, what effect does an overcharged system have on compressor operation during an emergency? A. Decreases compressor workload and energy use. B. Causes liquid slugging and potential compressor damage. C. Has no effect on compressor function. D. Increases refrigerant velocity, improving cooling. Answer. Correct answer. B. Explanation. An overcharged system may flood liquid refrigerant into the compressor during startup, leading to liquid slugging, major cause of mechanical damage and failure. Option B explains this critical risk. A and D are false. C ignores the impact on compressor health. Question 30. In light of recent developments, Mr. Garcia prepares for refrigerant recovery involving mildly flammable refrigerants. Which PPE is mandatory for this operation? A. Standard work gloves and safety glasses only. B. Full face respirator, flame resistant clothing and chemical resistant gloves. C. Surgical mask and cotton coveralls. D. Earplugs and steel-toed boots only. Answer. Correct answer. B. Explanation. For our refrigerants with mild flammability, OSHA and NIOSH recommend flame-resistant clothing, full-face respirators to avoid inhalation, and chemical-resistant gloves to prevent skin exposure. Option B meets these standards. Options A, C, and D lack respiratory or flame protection.